So when we talk about the transformations of rational functions, we're really just talking about the transformation of polynomials and polynomials that are flipped upside down because they're rational. So to recall that, let's start with what we know about polynomials and their transformations. So this is an equation that should look familiar to you, where a is our stretcher, stretches the function, and it stretches it when it is greater than 1. But it can also shrink the function. And that is when it's between 0 and 1. So when a is between 0 and 1, it will shrink because it's a fraction. All right, h is our horizontal. So it is a shift in the horizontal. It shifts right. And this is the one that is kind of counterintuitive. You think right is when h is positive, but no, when we have a negative h. So if it was a negative 2, then it would move to the right 2. And then we shift to the left when it is positive. That's h. Lastly, k, we have a vertical shift, and then this is the one that makes more sense. So we have it shifts up when it is positive and shifts down when k is negative. Okay, so that's what we know about polynomials already. Now, let's take this equation, and we're going to look down here, and let's change one thing about it. Let's take this x plus h, and let's just do the inverse of that. And so what I mean by that is now I'm going to replace x plus h by 1 over x plus h. Plus h. So this a is still being multiplied out front. That k is still being added on the outside. But let's simplify this a little bit further now. This a is really just a over 1. And so we can multiply these two fractions. 1 times x plus k, or plus h, is going to simply be x plus h on the bottom still. And then a times 1 up top is just going to be a. We can't really simplify this plus k any further. That's just going to stay there on the outside. But now you can see that this is actually what our rational functions kind of look like. We kept all the same letters. We kept a, h, and k and our variable x, and we just switched it so that the x plus h is now in the bottom. That's what a rational function kind of is. The most basic rational function. Okay, so now this isn't going to change anything about what these three things do. In this equation, a is still going to stretch it. It's going to stretch it when a is greater than 1. It's going to shrink it when a is less than 1 or greater than 0. This h is still going to be our horizontal indicator. So when it is positive, it is going to shift it to the left. And when it is negative, it is going to shift the rational function to the right. And then finally our k. When it is positive, it again shifts it up, and then when it is negative, it shifts it down. So it's really nothing new. We just have to interpret the new locations of these variables in our equation. So let's use that, and let's now write the equation for the location of this red function. I've already plotted in blue here the basic 1 over x equation. So in blue, you're seeing 1 over x. But in red, it's something else. To start, I always just write in my asymptotes. It's so much easier to see the shifting of everything once you have these two things in there. So there's my original function. The asymptotes cross at the point 0. And then my asymptotes for my new function. See if we can make those a little bit clearer. So that asymptote, it looks like, is right at x equals 3. And my other one, my horizontal, is right here at y equals 5. So now I can see that my function has gone up 5 and over to the right 3 from the asymptotes. So when I'm writing this, the equation, we're going to assume that a is 1 because that's going to take a little bit more advanced of a level to determine whether that's a 1 or a 2. We're only going to be dealing with positives and negatives for a. All right, now the x on the bottom, and it has moved over to the right 3, so that means that it is a negative h value. And then on the upside, we have plus 5. Okay, there is our equation for that red rational function. Let's move over to the other side. Again, I have plotted our original. This is the basic rational function 1 over x. And then in green, I'm going to go through and put in our asymptotes for our transformed rational function. And it looks like it actually has a horizontal asymptote in the same location. Okay, so in this one, our function that has been transformed has moved to y equals negative 3, because I can see that it's gone over to the left 3, 1, 2, 3. And then x, sorry, I misplaced my variables there. So that's actually, since it's a vertical, that is going to be an x, easily confused. And then our horizontal asymptote is at y equals 0. So our 1, is it positive or negative? Well, I can see now that my function, it's not like this one where there was something in that first quadrant going from that direction to that direction. It's not over here. It's actually over here and down here. So what's happened is the function has reflected the function from up top down to the bottom. And so what that indicates is that there is a negative in front of my 1. My a is at least a negative. We know that much. X plus 3 to make it move to the left 3. And then we don't have to add a k value because it's 0. We could put plus 0 if we wanted to. All right, so that is a basic overview of how to identify the transformations of these graphs. Make sure to plot those asymptotes and you'll be okay.